Alrighty, so today what we are focusing on is something called vertical motion, but really it's just another side of quadratic problem solving, okay? So we're gonna look a little bit more at graphs today than we did earlier this week when we looked at, or I guess end of last week when we looked at setting up the equations and factoring and things like that. So this equation that we start with, h of t equals negative 16t squared plus vt plus s. That is our general equation for any object that's being thrown, projected, kicked, any object that's being pushed with some sort of force leaving the air or leaving the ground. Okay? And parabolas are do a really good job of demonstrating the path of any object that is projected into the air. Okay? This is a formula that you need to be very comfortable with. You do not need to memorize it, but you do need to know how to plug in to this formula. Okay? This negative 16t squared, that's always going to be there. Okay, well, let's start with the h of t part. What do you think the h represents? Height. So this is height as a function of time, okay? And this is height in feet and time in seconds, okay? Is equal to negative 16t squared plus vt. V is the initial velocity, okay? So it's the force, basically, that it's leaving with. And s is the initial height. So those are the two values that are going to change, the v and the s. The negative 16t squared and the t are always going to be there. Okay? So, for example, if a ball is thrown upward from a point 8 feet above the ground with an initial velocity of 49 feet per second, the equation relating its height at time is h of t equals negative 16t squared plus 49 plus 8. So do you see how they plugged in the 49 for the v? Yes. And the 8 is the initial height, so that became my s. So you've got to be able to read a situation and plug in and write your equation. Everyone okay with that? All right, so let's go ahead and try and write this equation. A ball is thrown upwards at an initial velocity of 44 feet per second. The ball is 5 feet above the ground when it leaves the thrower's hand. So write an equation of the height as a function of time. So we're going to have h of t is equal to, how do we always start? Negative 16t squared. Okay, then what? Good. Plus 44t, because 44 represents the initial velocity. And then what? Plus 5. Good. Because 5 feet above the ground is the starting height. That's how you can remember that S is like where it starts. Everyone okay with that? Okay, so now we're going to kind of refresh some of the things you did in Algebra 1 of using your graph on your calculator to find these different values. Now, if you'll flip over onto the back of your notes, you'll see that there's kind of like a cheat sheet.
We have to memorize this?
Yes, these are kind of to help refresh your memory as you're working through your homework and stuff. You will not get to use this on the quiz next week, but the more you practice it, the more it's going to become really natural. This is just to help keep you from getting totally stuck on your homework. Okay, and as you're studying to like refresh your memory. It's a lot of words, but it's meant to help you when you're like on your own. I'm not going to refer to it so much today, but it's there for you if you get stuck tonight. Okay? All right, so go ahead and go into y equals on your calculator. And let's go ahead and enter in our equation. Couple things you want to be real careful about. Make sure you do a negative 16t squared Okay, you can use x, sorry, instead of t.
Is it even
Don't use a minus, and don't forget the negative.
solid?
Mhm.
What happens if you do use like you put in the letter T in your equation?
In this form, in y equals, it's meant to graph function of y in terms of x, so it probably will not graph. All right, so negative 16x squared plus 44x plus 5. Everyone okay? All right. Now, normally, we start at zoom 6, right? That's where we normally look. Which doesn't give me that bad of a picture, okay? But you want to be strategic about your window. What is our domain values? What are our x values representing here? What, Ben? Seconds. So are we at all interested in negative seconds? No, not in this graph. Okay, so that's one place that we're going to adjust our window. Also, we know it starts going up. We can't see the peak, but we can see it come back down. So we know we're also going to need to increase the Y max so that we can see the peak. So your window button is right here. The X min is the time minimum. We don't really care what's going on past 0, so you might set that at like -1 instead of 10. Okay, I would not mess with the scale. We saw the graph come back down, so we don't need to mess with X max. We do need to mess with the Y max, though, because we can't see the top of the graph. There's no rhyme or reason to what you do here. I normally double or triple it to start. You might have to guess and check a couple times. Okay, so I'm going to start with 20. Again, don't change your scales. Don't change any of that. You're only ever going to mess with X min and max and Y min and max. All right, and then press graph again to see how we did. We didn't get it quite yet. So what needs to be adjusted? The Y max. So what do you want to try now?
40.
40, all right. Did it work? Very nice, very nice. Your window doesn't have to be exactly the same as mine, okay? You might have tried 50 and it worked. That's fine, okay? The goal is that you see where it starts, the peak, and where it comes back to the ground, okay? All right, so let's look at our first question. What is the ball's height after half a second and then after 2 seconds? Okay, so let's think about it. What are we given? Good. We're given that t equals 1/2. T is our independent or our dependent value? Independent. It's what we're plugging in, right? So we are looking for the height. We're looking for the height. So what you can do on this one, and you might want to jot yourself a little hint or reminder, what you can do on this one is you can do second, calc, which is right over trace, and you see where it says value? You can ask your calculator to calculate the graph's value at any given independent variable. Okay, so I'm going to choose 1, and then it says x equals blank. What x value do we want to plug in?
0.5.
1/2 or 0.5?
23.
And then you press enter.
Can you also do that on the graph? Like you can put in the table statement.
Yeah, you can also use the table for that. Absolutely. Okay, so 23 is what we've got. Now, you cannot just write 23. What do you have to write? 23 feet. You got to show me that you know this is time. All right, now let's find when t is 2 seconds. Take a sec. Don't call it out, please. All right, what'd you get?
29 feet.
29 feet. Everyone okay with that? Okay. I'm going to draw us a little sketch of our graph, just so we can talk for a minute. Starts 5 feet above the ground, so would you agree it starts somewhere like here? Goes up and comes back down, right? Okay. The next question says, where does the ball hit the ground? What does that mean?
Where it hits the x-axis.
Good. Where it hits the x-axis, where the height is 0. Okay? Where the height is 0. So there's a bunch of different ways to do this. I'm going to show you the way that the cheat sheet on the back tells you. If you know a different way, if you would rather find the intersection with the line y equals 0, any of that stuff, that is totally fine with me. But I'm going to show you the way that's on your sheet in case you get stuck. Okay? So what we're going to use here to find when the height is 0 is we're going to use second calc 0. So let's see, second calc, and I'm going to use number 2, 0. All right, when it says left bound question mark, that means you go to the left of your 0. So I'm going to arrow over. You only use right and left. Don't use up or down. I'm going to arrow over to where I'm still to the left of my 0. And I'm going to press enter. And then what does it say? Right bound. So then I'm going to keep pressing right until I am under or to the right of my 0. And I'm going to press enter. And it says guess. You do not have to guess. Just press enter again. And then it will calculate your 0. Okay? You're always going to round to the nearest thousandth unless instructed otherwise. On the calculus exam, you will have to round to the nearest thousandth, so that's always your default. Okay? So what this means is at time what? 2.859 seconds. The ball is on the ground. Who needs help? Question, yes. When you find like the left bound and the right bound, doesn't matter. The closer you are, the more exact your calculator. Other questions? Yeah.
It's got 2.6 here, but it has...
That just means 0.
Okay.
Because it's 0.00000000001.
Okay. Okay.
You're going to want to try and change it, though, to where it's giving you more decimals. Because 2.6 isn't going to get you the exact answer. Okay? Or you might want to practice with one of these. I don't know. Okay. Yeah. You can, but you still need to be exact at 3 decimal places. All right. I need your attention back, please. Okay. Now we are asked for the maximum height. The maximum height. Good. The maximum height is this point right up here, right? The vertex. That's the max height. So what we're going to do is we're going to do second calc max. So let's try that. We're back at our graph. So second calc. And then you'd pick minimum or maximum. This time we want maximum, so that's 4. Okay, so again it asks us left bound. So what that means is you have to move your cursor to the left of your maximum. You don't have to go super far, just make sure you've gone back down. Okay? And then what do you think we do?
Go to the right.
Yeah, press enter and then go to the right of the maximum. Make sure you go up and then come back down and press enter. You don't have to guess, just press enter again. Okay, and we get this right here. All right, now go back and look at your question one more time. It says, what is the ball's maximum height? So which of these values do we want? Y. Good. So the maximum height is 35.25 what? Feet. You will lose points for not putting units. Okay, you have to put units on every answer. I gotta know if you know that it's time or feet. Okay, now look at the next question. When does the ball reach its maximum height?
At
So that would be
1.3.
1.375 seconds.
Good, that one is the x value. So that's gonna be at t equals 1.375 seconds. Yeah, Sophie?
I know for time you do to the nearest thousand. What about height? Isn't it?
Always.
Thousands for this one?
Yeah, but since this one would be 0, we don't have to put it.
Okay.
Just unless you're, like on the quiz, it might say hundreds. If it's whatever the instructions say, do it. But if you're not explicitly given instructions, you want to round to the nearest 1,000.
Okay.
Okay. When will the ball be 15 feet above the ground? Okay.
So you like
This time, this 15 feet above the ground represents what? Guys, quiet down, please.
Why?
This represents that y is equal to 15. So what we want to do is we want to figure out when this parabola, the path of this parabola, the path of this ball, hits 15 feet. How many times do you think it's probably going to happen? Twice. So what you're going to do is you're going to put in y2, you're going to put 15. So go back to your y equals,
that.
and in y2, you're going to put 15.
Oh.
Oh, that's smart.
So what we can do now is find these two intersection points. Okay? So you put the y value you want in the y2, and then we're going to find our intersection points. We're going to have to do it 2 times. So to find the intersection point, it's second, calc,
Like, whoa. What were you doing?
second, calc. The 5th option says intersect, which is what we want. And then you've got to pick which one you want to do first. Okay? I do the leftmost one first. It's just what I do. So I'm going to move my cursor until I see it come close to my leftmost intersection point. Y is what? Like what? Because you're maybe not moving right or left. You can't use up and down. You have to use right and left. All right, and so then I'm going to press enter, enter, enter.
Wait, on the point that you think it is?
Close to the point you think it is, yeah. You move your cursor close to the intersection point and then press enter 3 times.
Wait, how do you draw an intersection?
You go into Y2 and you put Y2 is equal to 15.
Oh,
All right, so the first time that this happens is where? At 0.25 seconds. All right. So those of you that were a little confused, watch as we do this again, because now we start the process over. I do second, calc. I choose 5 for intersect. I move using my right and left. I move my cursor to the intersection point I'm interested in now. Be sure you move your cursor, otherwise it'll just give you the same values you got before. Okay, and once I'm close, I press enter, enter, enter. And that gives me my second intersection point. So what's the second time that happens? 2.5 seconds. You would need both of those times in order to have a fully correct answer. Okay? So to do that, we plugged into Y2, and then we did second, calc, intersect.